Do you live in a house or an apartment? Do you sleep in a bed? Do you eat? Do you wear clothes? Do you buy online? Then you are a freight generator. And you're not alone. Demand for freight transport has increased throughout the years and will increase in the next years and decades. Freight transport is an important sector, representing almost 8% of national GDP and employment, and it sustains our daily life and economy. On the other hand, we see that transport in general has some externalities like congestion, air pollution, climate change, which has an effect on society and environment. That effect is estimated on almost 5% of European GDP. Freight transport is organized mainly through road, and we can say that how it is organized today, it is not sustainable. Continuing with business as usual will inevitably also have an effect on the CO2 emissions, and they will also increase. This is not in line with the goals of national governments, for example in Belgium, reducing the non-ETS sectors by 35% in 2030. On regional level, which represent the transport sector, we see that Flanders wants to have a reduction of CO2 emissions by 4% for freight transport in 2030. And on a European level, we see actually the goal to have a zero-emission urban distribution in major cities by 2030, and a reduction of transport emissions by 90% according to the Green Deal. To get those goals, what should we do? It's not an easy question, and it's only possible to answer that question by simulating actually the future. To do so, you need transport models, and VEB MOBI has developed such model. The Trabant model is a transport agent-based model, and it's a freight transport model for Belgium. It simulates freight transport for road, rail, and barge. It consists of different steps where we are top of the market within Belgium. We have a freight generation model, so actually it generates freight demand, so actually freight going from A to B. It's an agent-based model where transport companies are simulated. For those transport companies, we have real-world data. So their depot, their real-world place, the real place of their depot, and their real fleet. And actually what we do is we simulate their behavior, so how they economically optimize their routes and their deliveries. To do so, we use congestion. So we put passenger cars as background on the network to have a real congestion. Trabant has been validated throughout different projects, which for the Flemish government, Brussels and Walloon government, but also for companies like Turs and Colruyt. And Trabant allows to have really in-depth external cost calculation for air pollution, climate change, accidents, congestion, and so on. In the past, we did some simulations for, like I already mentioned, of which one for the Flemish government, where we developed a roadmap for freight transport for Flanders. There we simulated 15 individual measures to reduce CO2 emissions by 2030. On the graph, you see that the line of 1 is representing the situation in 2005. If we do nothing, we have an increase in CO2 emissions by 90% in 2030 for freight transport. Doing something, so one of the individual measures decreases that impact of CO2, but we will not be able to reach a goal of reducing 4% of freight transport in Flanders. So we will need to combine different measures. That is also what we did in that study, where we actually combined different measures in a simulation, and we looked at the impact of individual measures. There we see that actually the main reduction is obtained through vehicle technology and accompanied by phase out in major cities in Belgium. And that's an important one. We will need an available vehicle technology and zero-emission vehicles to meet the climate goals for freight transport. And we need it fast. In another study for diesel, for the Brussels government, where we looked at the implementation of a diesel ban and a petrol ban in Brussels, we actually see that at the current rate, we will not be able to have a good transport system by 2030, implementing the diesel ban, implementing a zero emission. Sorry. If those vehicles, zero emission vehicles, are not ready, heavy duty vehicles will be replaced by zero emission vans, and we'll have more vehicles in the city, more congestion, more air pollution, noise, and accidents. And this is where MOBI plays a crucial role. With the different expert tools, enabling like the ATEC side with the vehicle technologies and the predictions there, and our simulations to an external cost calculator, we are able to do research and to help the freight transport sector to be more sustainable and to reach those climate goals.